All right.
Hi, everyone. Good. Okay. Hi, everyone. Sai Devalapalli. I lead the analytics line of business for Dell EMC's unstructured storage group. So unstructured storage, unstructured data storage basically consists of file storage, object stores, software-defined stores, and you can probably tell I'm from the EMC side of the house, coming from the EMC side of the house. And since the acquisition last year between EMC and Dell, the companies have gotten together and figured out, okay, what is the portfolio of solutions that we can build out specifically with regards to analytics and Hadoop that'll help our customers take a much more use case driven approach towards taking infrastructure decisions. So rather than saying, hey, here's the infrastructure, let's figure out how to build use cases around it, look at your use cases, look at your workflows, and then define what your infrastructure strategy and your cloud deployment strategy needs to be. So that's what we're going to talk about here today. And in fact, I have here with me, joining me, is the head of Big Data Solutions, essentially Power Edge Solutions for analytics and Hadoop. He's the head of sales for that for North America, Anthony Dina here. And he actually hails from the Dell side of the house. So you can see how we're working together between the Dell and the EMC side of the house, building out this portfolio. So Anthony and I have been working together on this for a long time now to get this out. And we also have Matt Hausman here. Matt. So he's responsible for marketing for these solutions, for analytics and Hadoop solutions. So the three of us are going to be here for today and tomorrow. So we'll be happy to sit down with you guys and kind of discuss, stuff that you see here now. All right, so let's get started here then. How many of you guys are on the business side of the house? Raise your hands, please. Okay. How many of you guys are technologists? Okay, all right. So let's talk about the digital transformation that a lot of companies are going through today or are trying to drive through today. So digital transformation essentially allows companies to be able to implement specific use cases that either affect their bottom line or their top line, right? And a lot of it is driven by data, right? The availability of new data sources, such as from companies' own customers, enterprise IT systems getting upgraded, from mobile devices that customers are starting to use and employees are starting to use within companies, and then for OT companies, so operational technology companies, right? In industries that are OT specific, you have these IoT devices, right? Devices with sensors on them generating data. So there's a lot of data that is getting generated, and it's expected to be 44 zettabytes by 2020, that companies are trying to leverage to essentially transform themselves into digital enterprises. And they're trying to do so that they can implement these type of use cases and be more competitive in nature, right? So this is kind of mom and apple pie. So, and there are a lot of technologies that have evolved in the process of that journey for companies, right? So we all talked about the BI technologies earlier on the day, and then that has evolved into some of these advanced technologies, machine learning, predictive analytics, real-time analytics, so forth. And BI is still relevant. Everybody uses it still. So these are considered kind of enhancements to BI, right? Where you're trying to offload some of the processing here and do some advanced analytics on top of that. And along with those technologies, you also have kind of a Cambrian explosion of ecosystem of tools and vendors above and beyond the typical enterprise data warehouse vendors that we're all aware of. So you have these ecosystems such as Hadoop, for instance, right? You have vendors such as Cloudera, Hortonworks, Pivotal MapR, You have streaming analytics applications and tools that are being driven through open source ecosystems, such as Apache, right? There's been some discussions about Spark and Flink and Storm. We're going to double click on some of these later on. And then you have these purpose-built analytics platforms, such as from SAS and Splunk. Okay? And what's missing here, what's not shown here, is object store, the NoSQL type of systems. So those are also evolving. So there's a plethora of ecosystems and applications that are evolving. So what is the strategy when it comes to infrastructure, right? And what is the infrastructure's point of view when it comes to analytics and Hadoop use cases? Okay? So we look at it from a taxonomy that's kind of shown this here, right? So we start off with real-time use cases. And from an infrastructure point of view, that means low latency, rapid response. It could also mean high throughput. It could also mean high IOPS, all the way to batch mode and reporting analytics. And in batch mode and reporting, you're not concerned about latency as much. You're certainly concerned about throughput if it's large batch jobs. And you're concerned about capacity density. You want to have a lot of data be managed without having to bust your budget, right? And then you have data discovery and visualization type use cases that are kind of sitting in the middle. So it's good to kind of lay this out in a taxonomy so that you can actually make the right infrastructure choices. The other dimension to this is the type of workload that you're going to be running. So for these workloads here, the infrastructure decision can actually drive the performance and the cost and the overall return of your investment. So machine learning, right? If you look at machine learning workloads, a lot of them have iterative refinement built into them, right? So you iterate on the same set of data over and over and again until you purify that data, right? That's how most machine learning algorithms work. So what that means is you need to be careful about figuring out, okay, what does that mean in terms of my CPU, my memory, and my disk, okay? To be able to implement machine learning algorithms effectively. So that's a use case that can actually be influenced quite heavily, can actually influence your infrastructure decision quite heavily. Same thing with distributed IoT, right? So in distributed IoT, you have these devices and you have small offices and edge offices. You have central offices that are all generating data. You need consistency. You need authentication, authorization, those kind of things. The standard things that you need in distributed systems, you need those kind of capabilities. So the infrastructure decisions there are also important for those kind of workloads. So let's kind of look at the overall landscape of what those infrastructure considerations need to be for analytics and Hadoop workloads. So we talked about the use cases. The type of data and the volume of data is also a key factor for picking the right type of infrastructure. So you have hot data that's frequently accessed, and you have cold data that is less frequently accessed. And you could have data that ranges from the terabytes all the way to petabytes of data, right? And you could have different deployment models. So you could have an on-prem model, you could have a cloud model, or you could have a hybrid model that you choose to deploy your infrastructure, or use your infrastructure, I guess, in a cloud-based model. And then you also have to define what your operational models look like. So what we mean by that is you need to figure out if you want to go the DevOps route for application development, or you want to go the traditional lifecycle management route, right? And there are different consequences and trade-offs between the two. Also, virtualized versus bare metal is another consideration, right? You want to go virtualized, you want to go bare metal. So at the end of the day, all these considerations really boil down to the trade-offs and the balance that you need to strike between four things, right? Cost, capacity density, performance, and risk and compliance, right? What is the business risk you're taking? Are you going to be compliant? Are you aligned with all the regulatory requirements? Those are the four considerations. So let's look at the infrastructure strategy from the point of view of use cases and data. So if you have real-time use cases, low latency requirement, okay, potentially high IOPS requirement, and you have hot data that needs to be frequently accessed, the ideal configuration for that is what is called as localized storage. So localized storage is nothing but you keep the storage local to your compute on the same node, on the same server, and then you copy the servers to scale out, right? That's a typical DAS model, and DAS is an acronym that stands for direct attached storage, right? That's how Hadoop came along. That's how a lot of the analytics platforms are built, really suited for that. So you're looking for high performance and lower cost. So that ratio needs to be, you're trying to minimize that ratio, right? On the other hand, if you have large batch jobs, and if you have data discovery and visualization type workloads, and you're working with cold data, and typically cold data means that it's less frequently accessed, and typically it's longer lifetime data, so you could be storing data for like a 2-year period, but you still want to be able to analyze it. It's not archive, right? So for that kind of thing, you're not focused so much on performance per se, but you're focused on capacity density. So you want to store that large volumes of data very efficiently and still be able to do reasonable analytics on top of that. You will not be able to do real-time analytics on that, right? And that would be hot data. So for those kind of requirements, then a shared storage would actually make a lot more sense, okay? And shared storage is where you're actually sharing your storage in one place. And you still have your analytics stack, you still have your Hadoop stack, and then you point your shared storage to actually store and manage the data. And we'll double click on that shared storage because it kind of, sometimes you look at it and say, well, the whole point of having DAS for Hadoop is it's scale out, right? If you're using shared storage, then it's not scale out. Well, there are options for scaling out shared storage that we'll talk about. And a lot of you guys may have seen this graph on how the data budget, the data volumes are going up exponentially, but the IT budget is kind of flat, and there's a gap between the two. A lot of the companies that we talk to, it turns out that that gap is actually attributable quite significantly to cold data. So this is data that companies are collecting that they can get rid of because of requirements, regulatory requirements and such, and they want to be able to analyze, right? So if you look closely, it's actually a ton of cold data that is actually causing this explosion of data growth in a lot of companies. So for that kind of a scenario, shared storage could actually make sense. Okay? So let's double click on those concepts. So localized storage, direct attached storage. So you have compute, scratch, and storage all together on a single server, and you scale the servers out. And the focus is on high performance at low cost. And you have a wide variety of use cases, all the way from real-time to batch use cases that are possible on shared storage. And machine learning is a very suitable workload for localized storage. And the reason for that is because of the iterative nature of machine learning algorithms, right? You don't want to put those on shared storage. And you have multiple deployment models, and you have multiple operational models for localized storage. Now, shared storage, on the other hand, you're sharing the storage with other IT applications outside of analytics. Okay, that's the concept of shared storage. So you're not only storing your analytics data, right? Your Hadoop data, or your Splunk data, or your SAS data, or your Spark data, but you're also storing NFS data. You may be storing your Microsoft SMB data. You may be storing object data. You may be storing other types of data. So what you're doing is you're consolidating data into a shared storage, and you're able to tier it, right? You're able to have different performance tiers within that shared storage. Now, some people say, well, this just goes against the whole DAS model, right? And why should we even do this? Well, technology kind of follows a cycle, right? So there was shared nothing, which is great until you hit around 100 terabyte price range, and after that, to share nothing, you need to be building out linearly the hardware. And a lot of companies, that's not economical because a lot of companies are having to store more and more cold data as they exceed that 100 terabyte threshold. And that's what we're finding out. So that's where the shared storage really comes in. The other beauty of shared storage is that you keep the data in your IT system, in your shared storage, and you just point the analytics stack to it. So you could have a Hadoop, you could have a Hortonworks cluster, or you could have a Cloudera cluster, or you could have a Splunk cluster, and just point it to it. And the way you would do that is the shared storage would actually expose file interfaces northbound or object interfaces northbound. So it could expose an HDFS interface northbound. It could expose an NFS interface northbound. So what you're doing here is you're actually bringing the analytics to where the data exists, as opposed to taking the data from an IT system and then moving it into an analytics engine, right? So it's a paradigm shift. But it's only applicable if your use cases are around data discovery and visualization and batch mode use cases. So use cases that don't need the stringent latency requirements of a DAS system. And it's also relevant only when we're talking about data that's over 100 terabytes. This is kind of the magical threshold that we've seen a lot of companies go through and say, okay, we need to deploy a 1 petabyte system, right? How much hardware do we need for that? Well, it's quite a bit of hardware. But the question is, what is the frequency of access of that data? Can you put some of that data into a colder storage? So that's what companies are asking for. At least that's what our customers are asking for. So the deployment models are on-prem and cloud deployment models are typical for this kind of a shared storage concept, and you can also do multiple operational models as well, right? So while this is kind of counterintuitive to the traditional Hadoop DAS model, customers who are maturing beyond the sub 100 terabyte range and starting to build out bigger and bigger data lakes are starting to look at how to consolidate data together. And distributed shared storage is an extension of shared storage. So here's where it looks like a shared storage to your analytics stack, but it's actually distributed across multiple data centers. So this is great if you have analytics that has to run across multiple data centers without complicating your analytics applications. So your applications still run in the same analytics stack, but your data could actually be in multiple data centers. And how you split it across multiple data centers could be based on policies, it could be based on lots of other things, right? You could have different security zones or security realms based on local compliance issues and whatnot. So that's the advantage of having a distributed shared storage, is it hides all that complexity of the distributed model and then still able to run your analytics on top of that. And the deployment models are on-prem and cloud, but then you could also have a hybrid model. And the hybrid model is a no-brainer for distributed shared storage because you're essentially taking your on-prem stack and your cloud stack and you're calling it a single namespace. That's your hybrid model right there, okay? And again, you basically take your analytics stack and just point it to your distributed shared storage, okay? So double-clicking on that, how would distributed shared storage help with analyzing Internet of Things? So if you look at IoT architectures, you'll find something like this, right? This is a common IoT architecture, a directed acyclic graph where you have data sources from end devices coming in to either an edge processing center or a field office, and from there you have it going into centralized data centers, and then you have some sort of analysis that is running in multiple places, right? So it's highly distributed. So what would be the salient features of a distributed shared storage framework to address that distributed Internet of Things use case? So one is what is called as event time consistency. So you want to capture when the event actually happened, not when it was stored and forwarded, okay? And that's very important in distributed systems, right? Because you have delays. Distributed systems have to deal with unreliable networks. So that has to be built into the platform. You don't want applications to have to deal with those things. distributed shared storage needs the authentication, authorization, and audit becomes even more important when you're talking about distributed IoT. And then a lot of use cases, as distributed IoT matures, a lot of use cases need to deliver stream robustness. So robust streaming. So in other words, you want to be able to persist streams when you need to. You want to be able to replay streams. Okay. You don't want to necessarily lose streams based on the specific use case, right? So those are some of the features that a distributed shared storage need to be able to provide so that you can implement a distributed IoT analytics system. Okay? So these are all some of the strategies and the vision behind some of the portfolios that we have built between the two companies. So let's talk about that portfolio now. So we have three types of storage. We have localized storage. This is the traditional DAS type storage, direct attached storage. We have shared storage and distributed shared storage. So the localized one, we have two products. We have the PowerEdge servers, and then we have the VCE portfolio, which is VxRack and VxRail. Okay? Those are hyper-converged infrastructure products. And then for shared storage, we have the Dell EMC Isilon, which is a file-based storage system, but has a lot of native capabilities built in for things like HDFS, for instance, Hadoop Distributed File System. And then we have the distributed shared storage called ECS, and ECS stands for Elastic Cloud Storage. And it's shared storage, but it's distributed, so you have multiple data centers and yet a single namespace. Okay? So that's the kind of the execution of that vision. So just double clicking on these products then. So localized storage, between the two products, two sets of products, we have both converged as well as hyper-converged options. You could do bare metal, you could do virtualized, depending on what your infrastructure considerations are. We certainly have GPU acceleration on the PowerEdge side, and I know there's an NVIDIA session as well later on in the day to talk about that. We use NVIDIA as our GPU vendor. And for shared storage, as we talked about, capacity density is key, right? You want to have really high capacity density. So that's what these two products deliver. And they also deliver enterprise-grade file management capabilities, because if you're consolidating all the data in one place, you want to be able to do policy enforcement, regulatory requirements, data protection. All those things need to work on that one piece of data or one platform. Both boxes allow you to consolidate the IT workloads, so they support multiple interfaces, so NFS, HDFS, and so forth. And finally, they also do tiering between the boxes, so you can actually do different types of performance tiering. Okay, so what we have done here is then basically took our portfolio and integrated that with all the vendors that we talked about earlier on, and essentially baked these into pre-integrated solutions so that our customers can then focus on use cases and applications. And while direct attached storage is the most common, there are quite a few implementations of shared storage as well. So at the bottom here, you actually see the stats on how many customers are actually using the Isilon shared storage with analytics and Hadoop today. Okay? So again, these are customers that are a couple of examples here. So BAE Systems is a large defense contractor, and they have explosive data growth, and they had to do advanced analytics on top of that. So they decided to go the capacity-centric route in terms of doing their analytics. And they're actually using Cloudera in a compute cluster and then pointing to Isilon. And then that whole thing acts like a Hadoop cluster. And also as a file server, same time. Okay? And they also get out-of-box data protection and security and so forth, which is important for these kind of applications. NCC Media is another one example. So this one is where the customer was having to copy data from their IT systems onto their analytics platform on a nightly basis, and that was getting tedious when the customer data started exploding. So they basically decided to collapse everything into one platform and store both the customer data and then also do analytics in place on that data. So they have a Hortonworks cluster, compute cluster that they can just point to Isilon to do the in-place analytics. And some of the new innovations that are happening, we have a solution called Project Nautilus that actually embodies all the salient features that we talked about earlier on for distributed IoT. So this actually embeds Flink. I know there were some questions about Flink earlier on. And Flink provides robust streams as well as event time analytics. That's what differentiates Flink from Spark. And we are actually embedding this in our solution, and we're going to actually support that stack going forward. So we're going to basically package this up as a solution. We also have an open source stream persistence layer that we've built, and we've actually published to open source called Pravega that works with Flink to provide this solution, this distributed IoT streaming analytics solution. We also are building out validated systems with machine learning. So here's where you need to look at different types of resource pools for your compute, right? Some are memory-centric, some are compute-centric, some are I/O-centric, and then essentially build out your Hadoop cluster on top of that and use the machine library that best suits your use case. And then when you do this, you pick the right type of resource pools based on the workloads that your machine learning would have to use. So this is how you're trying to optimize your infrastructure for machine learning use cases. That's all I have. So the bottom line is there is no one-size-fits-all for infrastructure. If you're trying to expand your data lake beyond 100 terabytes or so, that's when you really need to start thinking about trade-offs between performance, cost, price, and compliance. And there are additional assets here, and the three of us are going to be here for the rest of the day today and tomorrow, so we'll be happy to discuss more.
Thanks very much, Sai.
Thank you.
That fourth guy looks really uncomfortable there. Any questions?
No questions?
There's one
Yes.
on the end, and the third one is as well. Yeah.
Yeah, there are a couple of them, I think. Yeah.
Good comment. Question? All right. Well, thanks for the presentation, and they'll be around to answer additional questions.